Jayaraman sir, shall we start the session?
Yes, we can.
Yeah, okay, sir. Tommy sir?
Yes,
Okay, sir. Thank you.
I am here.
Okay, sir. Good afternoon, one and all. Dear participants, hearty welcome to the final session of our STTP. Sustainability is another word for justice. For what is just is sustainable, and what is unjust is not. These are the words of Matthew Fox. I am really overwhelmed to welcome you to the session on Need for Sustainability in Project Designs by Dr. A.P. Jayaraman, retired scientist and former head of Media Relations, BARC. I cordially invite Professor Tommy Joseph, Registrar, Amaljodi College of Engineering, to introduce the resource person. Over to you, sir.
Thank you very much, Maureen. It's a pleasure and privilege to introduce such a wonderful person for the final session. Dr. A.P. Jayaraman is a retired and honored nuclear scientist and former head of media relations at Baba Atomic Research Center, Bombay. And he holds a long career spanning about 4 decades. He holds a PhD in science and postgraduate diploma in management. As president of STEAM Academy, he is very successful in spreading the goodness of science and engineering, especially among school students. He is the chairman of National Center for Science Communicators. He is the trustee of Indian Development Foundation, Mumbai, an NGO that works in the health, education, and development sectors. During 2007-12, he was a professor and academic dean of Southern Institute of Management Studies, Palakkad, Kerala. He is an eminent speaker. His TEDx talk on nuclear masala dosa is very famous. Also, he is a recipient of many awards: International Copernicus Award for Science Popularization, Manubhai Shah Award for Science Communication, Bhima Award for Children's Science Literature, etc. Thank you.
We welcome you, sir, for the session.
Thank you, Professor Marine. Thank you. Well, good afternoon, everybody. Thank you, Professor Tommy Joseph, for the lovely introduction. It is always pleasant to hear compliments, pleasanter still when it comes from a professor. So I had excellent post-lunch compliments. I thank you very much. Now, we are on the 6th day of this short-term training program organized by the All India Council of Technical Education. Now, the basic objective, as I understand, is that this should facilitate faculty to prepare our current generation of engineering students to be fitting, eligible, employable, and really attractive candidates in the knowledge economy. I think that is the objective. I must congratulate first the Department of Electronics and Communication Engineering for this majestic display of intellectual capital of 11 towering personalities of the profession who presented their views during these 6 days. You have been exposed to approximately 270,000 words of technical wisdom in 44 hours at the rate of 100 words per minute. I may be permitted now, I crave your indulgence to add another 10,000 or 12,000 words in the next 2 hours to add to that great technical inventory. Why should a fossilized, almost ancient nuclear technologist make a virtual appearance before you? That is an existential question. Why should I be here? What right have I got to speak to you? I examined myself in the mirror this morning because the best test which any engineer can perform is to look at oneself and see how eligible he is. Or as professors of management say in their classes, why did the chicken cross the road? why did A.P. Jayaraman agree to give a talk on sustainability? There are as many answers as possible to this question, but my confession is that I have been flirting with sustainability for the last 50 years. 40 years in an official capacity in the Department of Atomic Energy, and as 5 years as a professor of environmental engineering in the Singapore campus of the Griffith University. So that I thought is my eligibility certificate to be presented before you so that I can make my beginning. I will come to my first slide. And my first slide, this is my, no. I am showing a nuclear dome over here. This is not the dome of any of the Indian nuclear reactors. I am showing it as symbolic, as a global icon of sustainability. It has been sustainable to me because I had a sustainable career for 40 years around the reactor-centric activities, and about 10,000 engineers in the nuclear establishment also had very successful, sustainable career, professional trajectory, and very helpful living in this milieu. Now, not only that, after superannuation and retirement from dutiful service from the Government of India, they had equally sustainable, probably a little more sustainable life, quality of life, as well as standard of life. That is at the personal level. That is at the level of an employee. But as an establishment, I want to suggest and also to argue and also to advocate that sustainability is built into the nuclear reactor. If there is any complicated engineering system into which the nuclear, into which we have put in all things together, I firmly believe that the nuclear reactor stands in the front line of those engineering devices. I would like to make my presentation in two parts. Part one will be the concept, the current cutting edge understanding of sustainability as an engineering phenomenon, as well as the green engineering concept. My discussion or presentation of the green engineering concept will be based on current reading of engineering journals, more than that, inspired by my interaction and discussions with Professor Martin Polyakov, the world famous green engineer of the Royal Society, and also my short, brief, but very powerful interactions with APJ Kalam and Dr. Anil Kakotkar, who had been campaigning on the sustainable engineering projects, some details of which I'll be happy to share with that. My second part, which I will disclose in the first part itself, is that I will share my experience, my personal experience with nuclear power, with the desalination, particularly with the reverse osmosis technology, with the production of elemental phosphorus as a sustainable methodology of chemical engineering, and the production of electrolytic hydrogen. At a closer level, at a still more intimate personal level, I will share with you an electronic waste management project which we did in Mumbai as an example in which there was personal involvement. So that's my presentation outline. Now, when we look at the word sustainability, it sends a shiver through me. For the simple reason, I could find more than 200 definitions of sustainability in technical journals. Remember, these are technical journals which are discussing the sustainability concept. So first, let us look at a common understanding where we have the common denominator for discussion. Sustainability is the ability to use something in such a way that you don't use it up. So that's a paradoxical, almost oxymoronical discussion of the concept of sustainability. To use without using up. Well, that's what Webster Dictionary says, as well as Concise Oxford Dictionary says. But if we look at, let us say, the definition of the US Environmental Protection Agency, that the US EPA, they have given a guideline in the sense that there should be coexistence of human activities and engineering activities. It should be done in such a way that both have a dynamic equilibrium, and if you shift it forcibly into one aspect, the other will suffer. So US EPA has been very vociferously arguing for environmental protection by giving numbers, quantified numbers for materials and for the energy equivalent, so that one can calculate the exact harm or impact a particular activity in terms of materials and energy will have on the environment. So US EPA gives us the extremely good guidelines for this. Now, let us look at the American Institute of Certified Public Accountants. Now, accountants will always look at money or the lack of money. Now, where does money come from? The bottom line in all industry, we are in business to make money. No one is in business to lose money. So, your ability to get a return on investment, ROI, in the shortest span of time, that is the prime mover. That is the driving force for most of the industries. No one will start an industry with designed to failure and designed to make loss. And therefore, you will find the American Institute of Certified Purchasing Public Accountants saying that the bottom line, although the bottom line is profit, we should do it in such a way that doesn't clash with the stakeholders immediately, because then the survival of the profit-making organization will be in jeopardy. So therefore, they were willing and they were tolerating the concept of sustainability. If you look at the International Integrated Reporting Council, which was a little more towards the sustainability side, they said we need good, solid, sober activity in the sustainability aspects, and we want that to be reported. So that's what we find. We will come to the management's perspective, which is typically represented by the Harvard Business Review. And Harvard Business Review said that the resource depletion will be the major threat to the sustainability of an industry. And therefore, in view of the sustainability of the industry, it is necessary for us to have sustainability of resources. So that was a management perspective. And management perspective from HBR is particularly important because of the simple fact they define management as the art of getting work done through others. So if an engineer is going to get work done through other engineers, the primary factor that should overweigh, we should weigh in grudging scales what are the natural and probable consequences, what happens when we put in some material or some energy into a system. Then we have the more refined and sophisticated accounts from the Sustainability Accounting Standards Board. They were accounting not money, they were accounting sustainability. And therefore, they gave us more rigorous definitions for this. What I would now suggest is the GRI, the Global Reporting Initiative, is one of the most striking features of sustainability engineering today. And many engineers have qualified with the GRI certification. The GRI certification will give you a legitimate weapon to discuss with your consultants what they are telling you. If you don't understand their grammar, if you do not understand their vocabulary, if you do not follow their syntax and phonics, it will not be possible for an engineer to survive in the years to come. Because consultants who are experienced in GRI format will be discussing certain aspects, and we must be able to, as engineers, we should be able to understand their language and to reply to them in a language which they understand. Therefore, a company's cutting edge sustainability will depend upon the internal strength of the engineers in understanding the GRI perspective. Then we come to the classical operational definition of sustainability given by the United Nations. Now, that's the one where we have the sustainable development concept by Brundtland. Now, this definition is at once strategic in concept, tactical in implementation, and is operationalizable both in the local, regional, and at the global level. So this has been extremely important because way back in 1983, the United Nations Secretary General called the Norwegian Prime Minister and asked her to formulate the concept for sustainability as the guiding principle for the United Nations. And she wrote a wonderful book. A book, every word of it is now being quoted and cited throughout literature. That is Our Common Future. This is the fundamental holy book, the holy grail with which the sustainability concept is evolved. There was an Indian justice also part of this system, and he has also contributed for the jurisprudence of sustainability in this report, which is called the Brundtland report. Now, just to have a little, we'll spend a minute on this, her definition. Sustainability, she did not define sustainability. She defined a sustainable development. Sustainability is an abstract now, and therefore it is an abstruse concept. Without defining an abstract now and without describing an abstract concept, she gave a mechanism and she said sustainable development is the pathway to sustainability. So sustainability still remains as a concept, whereas sustainable development, the engineering activities that we promote and practice and nurture with as a pathway to achieve that status. The one is a goal and one is a mechanism. This has been a clear semantic distinction which she could bring. I'm using the term semantic distinction because the word sustainability or sustainable development as she has used is a semantic vector. We have studied in our physics that vector is a quantity which has got both direction and magnitude. The sustainable development SD is now defined as a semantic vector because of the fact that it is a direction and it is a magnitude. This is the engineering content which gives scope for improvement. Now, there are limitations, there are even insufficiencies, there are even deficiencies in this definition. For example, the definition says that sustainable development is that development which meets the needs of the present without compromising the availability of materials to future generations to meet their own needs. There comes a lot of qualitative expressions. Needs of the present. Present for how many people? Will it be for 8 billion today, 16 billions, 24 billions? So we have not qualified the multiplier fact, and multiplier is involved. Every human being, all of us are 10 watt thermal machines. Every human being is a 10 watt thermal machine. Now, the amount of energy we use, electrical energy itself, the amount of the food materials we consume, let us say 1 kilogram of food, 2 liters of water, 5 liters of oxygen, we are consumers. Now, are we planning a development program for 8 million, 16 million? That is a question. So present, we have to define the multiplier effect. Then future generations, is it enough I prepare for my next generation or for my grandchildren or beyond the grandchildren? What is the future? Tomorrow is future, 10 years is future, and future is an indefinite continuum into which it is moving. Therefore, this definition has the built-in deficiency of not being able to quantitatively tell us what to do, or more than that, what not to do. So that is as far as the definition is concerned. Therefore, now we come to the Holy Trinity, or the generally accepted. In fact, I'm particularly happy that yesterday my colleague, Professor V.K. Damodaran, has given an excellent exposition of most of these concepts from his perspective as an international consultant, and has prepared the ground for all of you to understand it so thoroughly and so comprehensively. So my job becomes much lighter. I do not have to enter into definitions and descriptions in greater detail, but I am doing some of these definitions, recapitulating, so that you will be able to have a better understanding of the case studies I'll be present from the nuclear point of view. Now, if you, as a civil engineer, if you look at the sustainability concept as a roof, this metaphor is important because you are treating sustainability as a built-in structure and a roof structure to which you are providing 3 pillars. Now, the essential criteria to be met with in the design and fabrication of the pillars is the economic pillar, the social pillar, and the environmental pillar should be of the same dimensions. Their size and their length should be identical. So this is one of the pillar model which we normally use at our environmental engineering classes. But more than that, it is also represented, these three concepts are always represented by spheres in a Venn diagram mode. Now the Venn diagram mode is important because it enables you to understand the interfaces between them. For example, if the economic sphere is interacting with the environmental sphere, we will find that you will find in the interface, what is important is the viability of a project can be designed. But the viability can be is only one aspect, is only 1/3 of the aspect. But if you see the social interface between society and environmental sphere, you will find that there is what is known as a bearability. For example, I am going to burn diesel as a diesel generating set, and I am letting the exhaust gases into my neighbor's area. Then as long as the neighbor says it is bearable, I may not have a problem. The moment it crosses the threshold and becomes unbearable, it will not be tolerated. So viability, and then again the economics, how much money I make from an activity, as well as how much I do in my immediate neighborhood. That is where the equitable distribution comes. So sustainability involves three fundamental factions, namely the viability, the bearability, and the equitability. Now, the interface of these three factors will be a narrow sphere, which is called the sustainable sphere. So we must understand that this is not only the relationship between the two factors, it is the relationship and the continual interaction between three parameters. The complexity multiplies by Greikuna's formula. Now, if you look at another action, which is the contemporary state of affairs, I'm not commenting on the state of affairs of the corporate social responsibility, how it is being handled by the industrial sector today. Then we have got what is known as the abominable Mickey Mouse model. In the Mickey Mouse model, we have the large sphere, the primary profit sphere, to which two small ears have been added, the environmental and the social. A bit of environmental and a bit of social, and we think we have done our duty. And this is where the application and the utilization of the CSR funds, which will tell you we have a sustainable facility over this. Now, if you look into the system of sustainability has been now well embedded in our system, but unsustainability should be understood so that sustainability can be differentiated. So way back 1970s, that's the year we were all in the atomic energy, and there were lots of literature coming on one concept, limits to growth, LTG. There was a great professor of systems dynamics in Massachusetts Institute of Technology, J. Forrester. And J. Forrester's system dynamics was the overruling intellectual capital of those times. And most of us were trying to understand at least the physical concepts, or at least at the conceptual framework or the theoretical underpinnings of what J. Forster was saying. Immediately after that, under inspiration from J. Forster, three people, Meadows, Donella Meadows, Dennis Meadows, and Rand, they brought out a book called The Limits to Growth. That was the most discussed, debated, and most argued about book, and which shows that the 5 parameters, that is the population explosion. In fact, the word used was population explosion because there was another book called the Population Bomb by Ehrlich. So Ehrlich's work of a population explosion, see an exponential rise of population, and there is an industrial output per capita increasing exponentially, and there is food consumption also increasing, and as a result of that, the pollution was moving towards a crescendo, and natural resources were coming down. When the nature of these ugly curves were examined by theoreticians, they found they are more exponential and less linear. That means based on this exponential model, they predicted that by 21st century, we would have exhausted most of our products and most of our resources to make products and processes, and we will be in difficulties. So that was the concept of limits to growth, which is revisited today. It has been revisited today. And most of the sustainability engineers are now concerned with the version 2 and version 3 of limits to growth.
Sir, Jayaraman sir?
What is it like?
I think Jayaraman sir has lost his connection. Participants, please wait. Jayaraman sir, can you hear me? Yeah, okay, sir.
I don't know whether you can hear me.
Yeah, we can hear you. But your video is not visible.
Bombay is on a blackout, and Murphy's Law has happened just now.
Okay. Oh,
Can you hear me now?
yeah, sir, we can hear you.
You can't see my slides.
Yeah, we can see your slides.
Oh, back to normal, back to normal.
Okay, sir.
This is not an instrumental failure or a technical snag on my part or my home part. The whole of Mumbai has turned to dark.
Okay, sir. Okay, sir, we'll continue.
Now, thank you so much for bearing with me. Now the point is, when we are speaking about this sustainability in practical terms, what can engineers do? I want to mention that the fundamental philosophy is based on Gandhian economy, but three great engineers, Abdul Kalam, an aeronautical engineer, Anil Kotkar, a mechanical engineer, Dr. M.P. Parameswaran, an electrical engineer, they have been doing the best work on sustainable engineering in this country. This concept was small to match, you will be able to do better. And he was against large scale investments, both in terms of money and people. Am I audible?
Yes, sir, audible.
Oh yeah, because I am just checking up because there's a power still available. Okay. So Gandhiji's basic philosophy was that this is very similar to Abraham Maslow's theory of we have the physiological needs, we have the need for esteem, we have the need for safety, we have the need for security, and then ultimately we should have self-actualization. That's what management schools teach about Abraham Maslow's theory of hierarchies. But the theory of hierarchies, which in fact the technical university to which you are members, APJ Kalam Technical University, Kalam has been working on this concept, and his idea was, I'm not referring to his missile technology or nuclear technology, I'm referring to his technology with respect to sustainable projects. For example, his project is known as PURA, which means providing urban amenities to rural areas. Providing urban amenities, what we enjoy in the cities, the bliss of cities, how to give it to the village people. That's what he wanted to do. And he applied the technology, advanced technology in villages. For example, all of you are familiar with the Kanjivaram silk saree. The Kanjivaram silk saree has a border which has a metallic threads running through that. The metal will be an alloy, border will be lined with copper, gold, and silver. That is the ratio in which these precious metals are used. The actual value, the quality of the border cannot be determined by an ordinary consumer or buyer because you have no non-destructive testing facility available for finding out the amount of gold and silver on that sari border. So with the help of the Kalpakkam Atomic Research Center and the neutron diffraction, the X-ray diffraction spectrometer available there, he set up a facility for finding out the quality control of these borders. This is what he has done by applying an advanced technology to a field situation. He also used isotope technology, isotope hydrology technology for connecting the reservoirs, underground reservoirs in the hilly terrains of Jharkhand and the Himalayan region. And he found out that, is the current field? Then he could connect that. Apart from that, he also developed certain technologies of the biological or the botanical one, for example, the Jatropha technology for biodiesel generation, and the Kalam stunt for bypassing problems in the cardiac situation. So those were certain things which he applied, and most of them were used as part of his Vision 2020. Now, coming back to Dr. Anil Kakodkar, former chairman of the Atomic Energy Commission, and also the architect of the Technology Vision 2035. In fact, the document, the Technology Vision 2035, is the ideal document for an engineer to understand the implications, what engineering can do in the immediate future, 2035. It is a very comprehensive document, a handbook for engineers to find out what can be done in the immediate future, 2035, and the way to, and the pathways and mechanisms relating to that. Now, Kakodkar has started a new program called Sillage. Sillage stands for city and village. And one village, Gopalpur, in Maharashtra, has been equipped with a lot of technologies as far as the rural technology is concerned. We have high-yielding varieties of groundnut being developed there. And not only developed, given to the farmers to produce yields which are conventionally 20 to 30 times higher than what they are having today. So that is hybrid mutants have been developed. Then he has also trained them that some of the old X-ray equipment are being renewed with appropriate electronic refurbishment. They can be made use, and many hospital equipments are now refurbished by cannibalization of products. That's another thing. And this rural technology has been used in a big way by the methodology which Kakodkar has developed. Now, coming back to home, the Integrated Rural Technology Institute, IRTC at Mulund, was a brainchild of Dr. M.B. Parameswaran, an electrical engineer of Trivandrum Engineering College, who joined the Baba Atomic Research Center. That's Atomic Energy Establishment, Trompe, in 1957, in the first batch of the training school, along with another 100 engineers or so, and he belongs to he stands in the vanguard of nuclear engineers. And today, you must also be knowing that the Kerala Shastra Sahitya Parishad, KSSP, and the rural technology, the entire things were developed by Dr. M.B. Parameswaran after having a prototype model having been developed in Mumbai. Now, all the three engineers are united in their conviction that the best of engineering can be brought out by the application of the Gandhian paradigm that the earth provides enough to satisfy every man's needs, but not every man's greed. So this distinction between basic wants, needs, and greed, that is precisely the problem they have differentiated, and they have applied appropriate solutions for that. In the design of these projects, in the design of almost all projects, it is necessary to avoid certain factors. For example, let us look at the most fundamental factor we have, that is the elements of the periodic system. All of us would have studied the periodic table in our 12th standard before we joined engineering. And we will know that there are 118 elements in the periodic table, starting from hydrogen and ending with organocene. These elements, 118, are not available in the same quantity and quality in nature for engineering purposes. As our industrialization moved from industrialization version 1 to version 2 and now on version 3, we find that there is a serious threat to many elements. For example, as many as are under serious threat. That is, they will vanish from the surface. And you will find that the one to your right, extreme right, helium. Most of us are using a large amount of helium for our birthday parties. And we are happy as it goes higher than hydrogen. And we are also extremely happy that hydrogen is combustible and inflammable, whereas helium is not. So we have ensured the protection and safety and safeguard of our children. So what a lovely solution we have got for birthday party helium. But the problem is the helium will run out as a natural resource and will not be available after 40 years. And then birthday parties will stop, but that's the damage, that social consequences are much less. If you look at the magnetic resonance imaging MRI technique, which is being used and which is a vital diagnostic tool for finding out many problems, there will be no hydrogen for that. That will be one problem we will face. Therefore, we have to take an account of what is happening today and the rate at which we are using it. Otherwise, we will run into a problem. 7 of them are already in trouble. 7 are facing extinction in the immediate future. And the rest of them are also not available in abundant or infinite quantity. 3 elements you should remember in mind that involves most of the materials required for modern electronics. That is gold, silver, and tantalum. These 3 elements are coming from 3 very conflict-ridden areas. Peace is lost. War is raging. Any moment the supply chain will be terminated. So an assured, uninterrupted supply chain of the critical strategic materials and building an industry on that will no longer be possible. These are the engineering constraints, the physical restraints which exist in today's world, and sustainability asks us to have a look at these factors. Now, we have been living with sustainability question marks. For example, look at around 12,000 years ago, when the hunter-gatherers, our great forefathers, were hunting and gathering food materials and were leading a nomadic life. And they thought it is good to have a sedentary life and start off farming. And when the technology, that time, let us call the farming technology, was developed, people were living in small colonies. They started agriculture, domestication of animals, and the Neolithic first revolution, the Neolithic farming revolution or agricultural revolution started. And they were happy for some time. But after a short time, we found that the cycle is not repeatable and the land gets infertile. The nutrients are lost rapidly. The number of people who could be supported by the land at that cleared area from the forest is small, and therefore conflict of interest and internecine fights started, and the Neolithic agricultural revolution came to a dead still. And more land acquisition moved. This is what happened. This is what history has recorded as a lesson in unsustainability for us. Coming back to recent times, we have M.S. Swaminathan, Fellow of the Royal Society, the father of the Green Revolution of this country, who brought in a Green Revolution with a rapid application, with a rapid extensive application of chemical fertilizers, nitrogenous fertilizers, phosphatic fertilizers, and potassium fertilizers in large measure. Also supplementing and reinforcing that application of chemical fertilizers with the help of insecticides, and therefore we were able to have a high yielding variety of, he also applied high yielding variety of agricultural seeds. With the result, we had a green revolution. We could produce more than we could consume. And when we could produce more than we could consume, and our granaries became strong, particularly in Punjab, and the plateau continued for quite some time, then the dip and decline started. That is the same problem, the same historical problem which is the Neolithic agriculture face is the same one which we are facing today, and therefore we are looking for a sustainable, greener agriculture, and that is the objective today. So I am now coming back to Professor Martin Polyakov, the iconic figure in green engineering, the towering intellectual personality who has been dominating the contemporary scene at the Royal Society. I had the privilege of meeting him and holding several discussions during this period. And he has been doing things. First thing he said as a chemical engineer, this is what we should do is conduct your chemical reactions at normal temperature. Every chemist will go for Haber process, nitrogen and hydrogen, enormous pressures, enormous temperatures, and catalysts. So chemical reaction is exemplified generally in terms of the Haber's process, high pressure, high temperature, catalyzed reaction. This is what it is. Now, a paradigm shift from this is what is necessary. And he said that exists. Chemistry and chemical engineering today can be carried on without assault and insult to the environment. So he developed what is known as Moore's law. Is known to most of electronics and the communication engineers. What it says in essence is this: the number of transistors per square centimeter or per unit area in an integrated circuit will double in 2 years, and the cost will come down to half the value. So when the number of transistors doubles in 2 years and the cost coming to half of what it is, we call it the Moore's law, and is believed to be true over a large spectrum of years. Now, Martin Polyakov modified this and called the sustainability law, or the Moore's law for chemicals. What he said was, every chemical is applied to any system, electronic, pharmaceutical, or whatever it is, for a function in order to produce an intended effect. Now, to produce an intended effect, how much should be applied? That how much we have been following a philosophy of absolute liberalism. Availability in the stores or the inventory has been the guiding principle controlling the outflow of materials. He said, if in a chemical system, the use of a chemical could be reduced by half in 5 years, if the quantity of chemical being used is reduced to half in 5 years continuously, and a number of cycles are followed, we can get a cycle reduction of 2 to the power of 6, which will be 64 times. We will be using 64 times less of that chemical if the Moore's law of chemicals is employed. So that is what he said. Now that is highlighting or underlining the importance of chemical engineers. Now, if you look at of course, currently we are thinking about the Millennium Development Goals, and the Millennium Development Goals were displaced by the Sustainable Development Goals, and SDGs are the ruling principles for any project anywhere at the governmental level, at the non-governmental level, everywhere, even the laboratory project which we do as a pilot project or a bench scale project, it will have the SDG signal to be applied. Now, the most important thing we have to bear in mind as engineers is the fact that engineers are the single critical variable for SDGs. SDGs cannot be achieved or attained or implemented without the active support without the active involvement of the engineering community. Engineering community, not only between academia and universities, between industry and business, with government and public sector, and the World Federation of Engineering Organizations, which has a membership of 30 million engineers today in about 120 countries, over 120 countries. These 30 million engineers have committed themselves to the realization of SDGs. That is the engineering commitment. Now we come to an aspect. I want to draw a distinction between sustainable engineering and green engineering. All green engineering is not sustainable engineering. I'll come to that when I come to. Now, green engineering has been defined as we should be able to design, we should be able to conceptualize. That is our primary, as an engineer, the first step, first tottering step we take into an execution scenario is the design. At the design stage, you make a faltering step, we will never not be able to do that. And therefore, this green engineering is the design and commercialization. That is when we do a prototype and we scale it up and we bring it to the marketplace. That's where we do the commercialization. And the process and products should be in such a way that they should have the minimum pollution on the environment. The pollution should be water pollution, land soil pollution, as well as air pollution. And the pollution as abatement and control of pollution should be built into at the design stage itself. At the front end of the design cycle, if it's not taken care of, it is not possible to inject it to somewhere as a mid-course correction. And therefore, promoting sustainability, protecting human health without sacrificing economic viability. It is almost asking the engineer to do the impossible. You have to achieve two objects at the same time. But today, the technology and methodology have developed to such an extent that it is possible for us to have absolutely green and greener engineering concepts. Now, we have the 12 green project design rules. Now, these design rules are extremely important. I have put 12 of these green project rules here. This will be a class by itself. So I will just refer to the first one aspect of it, that is the step 1, inherent hazard-free project design. Now, inherent hazard-free design rule states that this is largely coming from the chemical industry. Now, let us say that hazard is the probability that a substance under use will show its properties, its inherent properties. Let us take a chemical like benzene or trichloroethylene for cleaning electronic components. We have a PCB and we would like to clean it, and we have a possibility of using a chemical, and the most recommended chemical today is TCE or trichloroethylene. We can also use benzene, we can also use alcohol. Now we must be familiar with some of the very fundamental concepts of safety culture. The safety culture says that every chemical, no matter what it is, no matter what the chemical is toxic. All chemicals are toxic, including water. Now, water which we drink normally 2 liters a day, as long as we ingest water through the mouth, there is no problem. But if we are given an intravenous injection of 2 liters of water instantaneously, instant death is what will follow. Therefore, the route of entry is extremely important for a chemical. So toxicity is the inherent capacity of a chemical to produce an injurious effect at the molecular level. Whether you are using trichloroethylene or you are using benzene or whether you are using ethyl alcohol as a solvent or cleaning agent for the electronic components, its toxicity cannot be altered. Now, the engineer interferes here. The toxicity cannot be altered. It is genetic to the molecule. But the probability that the toxicity will be exhibited under conditions of use by appropriate engineering interventions, that is where the hazard is reduced. The ability to control the toxicity comes from engineering devices, and therefore hazard can be reduced and brought to zero, and safety can be brought to 100. This is the triangular relationship between toxicity, safety, and hazard. So having said that, if you are deciding a project, well, I am again coming to the 3 chemicals I mentioned for the electronic industry, namely benzene, trichloroethylene, and alcohol. We know that the threshold limit value, that is the concentration of The solvent in the air, if the concentration is allowed to exceed that, the lower level of concentration at which no hazardous effect will be exhibited, that is called the TLV. And TLVs for all chemicals have been designed by the American Conference of Governmental Industrial Hygienists. Now, if you look at the table of the Governmental Industrial Hygienists TLVs, threshold limit values, benzene is 10 parts per million, trichloroethylene is 100, and alcohol, C2H5 alcohol, is 1000. So that's the order of magnitude for benzene, trichloroethylene, and alcohol. Now, this threshold limit value is the one which is used for our exposure to our engineering environment. We are working inside the factory. Now, outside of the factory, the rule of the thumb is that 1/100th of it is allowed. That means only 0.1 of benzene is allowed, 1 of TC is allowed, 10 of alcohol is allowed. So you have a comparative rating for the solvents used in your industry, and this should be taught in the first instance. So that is what things move on. Now, this is called Engineer's Survival Toolkit. Now, if you look at this survival toolkit, this will contain 90 elements shown. This is actually, it looks like a periodic table, but it has nothing to do with the periodic table. There are accidental coincidences. For example, there are 90 elements in the 90 natural elements in the periodic table. 118 is the total number. Here also we have put the design control checks in the form of 90 checks have to be applied for every project you are going to take up. So every engineer will be familiar with this aspect. Now the usage of this is what Martin Polyakov was telling us. Martin Polyakov says, look at this, treat this as a periodic table. The extreme left of the periodic table where we have the group 1 elements, that is, let us say, lithium, sodium, potassium, rubidium, cesium, francium, and so on to the left. And to the right, we have got helium, neon, argon, krypton, xenon, radon, and organocon. That is extreme case, the periodic. In the periodic table of Polyakov, what we find to our extreme left is nothing but this is what we call the honored values of sustainability. And to the extreme right, we have got what is known as the, not the noble gases, but noble goals, what we should achieve. If you want to find out exactly how do we operate this system, and we should learn how to operate this system. If you press on A, or again, okay, let us see. The 12 rules have been described here. To the right of the periodic table, you will find conceptual frameworks. And the conceptual frameworks which we normally use are biomimicry, circular economy, and what is known as benign design. So let us leave this conceptual framework and let us go to the economic factors. The economic factors are life cycle costing, activity-based costing, ABC. Those things will come to where I saw the B over there. Then you come to what is known as F. So when you click on this periodic table, let us say you are clicking on Martin Polyakov's famous one, which I call the F factor. So you click this on the periodic table, you will find, and this is how Polyakov explains his periodic table to the students. You will find that we are using a particular chemical for an electronic industry, and he defines a factor called F factor. That F factor is nothing but the functionality of that chemical divided by the kilogram of chemical required. So you have a quantitative figure now from the periodic table. Now, on the policy side, if you click, there are 7 policy rules to be followed in the design features itself. And there you will find, in the case of electronic equipment, what is known as EPR, or extended producer responsibility. So if you are designing a system, you are just trying to use 100 CFL lamps for a certain system, the extended producer responsibility will let you know that the usage of these mercury bearing CFLs in the system will end up in a situation where you will not be able to dispose of the systems the way you want it. So therefore, I suggest that every engineer should familiarize herself and himself with the aspects of green engineering product design, the 90 principles of do's and don'ts, and you will get, for corresponding to each pigeonhole in the periodic table, you will find extensive technical data correspond to material data sheet of the US department. So when we come to I gave a very brief description about the sustainability development goals. And if you put all the 17 sustainability goals together and try to arrange, you will find at the center of this, if it's a circle, at the center, the radius, you will find energy is a single critical variable. No energy, no SDG can be achieved. Therefore, energy will continue to be the dominant factor. And if you want to see the SDGs distributed on the economy and society, the three pillar axis, then you will find 4 of them will fit into this, 8 of them will fit into society, and another 4 will go into the environment. So SDGs have to be fitted where they fit most. That was the next criteria. I spoke about energy, and I also I used the same classical which chairman of the Atomic Energy Commission were using right from Homi Bhabha's time as on today, that energy is a single critical variable for development. That has become axiomatic in my department. And they plot wonderfully well between Human Development Index, HDI, on the y-axis and the per capita power consumption on the x-axis. The correlation between these, although it looks like a cluttering of dots, there has been a beautiful curve over there. And that curve shows it rises pretty high exponentially, reaches with a lower slope, then saturates somewhere over there. The highest value for Human Development Index, the unattainable value, is 1. No one has reached. But till you have a per capita consumption of 1 gigajoules per year, there is a linear relationship between energy consumption and your welfare. If you have very low consumption of energy, you will not be having a good quality of life. Therefore, the quality of life is correlated very well in a linear way with high confidence level at this graph. And you will find India is somewhere at 0.6 in the Human Development Index. And you will find mainland China above us. Then you have the large countries, the United States, the affluent countries, the rich societies who are consuming, that is energy gulping economies. So that is also an unsustainable effort. So there is an effort to use energy at the lower end, Nigeria, Afghanistan, Zambia, India, and they are badly in need of hungry for energy. And there are people who are saturated, oversaturated with energy consumption. That's a pattern of HDI today. Surprisingly, have a look at Kerala. Kerala's Human Development Index is somewhere between 0.7273 or something like that. That is almost comparable with many of the Middle Eastern countries and with the European countries. So we are able to have a good Human Development Index with relatively low energy consumption, relatively low. I'm not saying it's absolutely low. There is an irreducible minimum of energy consumption above which only the quality of life will be visible, and that has been achieved. And this is what is being described as the Kerala model of development. And now there is also a statement that this is the, Amartya Sen has been saying, this is the Kerala model of sustainable development. Now, the engineering skills, particularly the engineering design skills most required for SDG implementation are, in the case of clean water, SDG 6 will be met, energy 7 I mentioned a little earlier. If you want a strong and resilient infrastructure on which only you can build a superstructure, SDG 9 is accomplishable only through engineering practices. Then the cities, the urban infrastructure is based on 11. And from the chemical engineering point of view, the responsible production and the business of industry is production, distribution, exchange, and consumption. How that logistic line runs is dependent on the engineering skill. And I'm not going into the education field because new education policy has come and it has a tremendous impact on higher technical education. That is for other experts to see. And now the Honorable Prime Minister of India has decided that we should make it in India. We should make it in India because one of the leading burgeoning industry, the economies of the world, China is making things and dominating the global marketplace with its own products. And unless we make in India, we will not be able to survive in the future economy. And engineers make things. The definition of engineering, engineers is this. Engineers make things. Engineers also make things better, and they alone can make things better. And if you want things to be made better and greener, no one else other than engineers can do. Therefore, the Make in India challenge, grand challenge, has to be accepted by the engineering community. I'm not going into the epistemological diagram by which we are finding a problem solution. Because in engineering, any difficulty we have, any mess we come across, or any trouble we have, it is not a problem. A problem is a significant difference between what is and what should be. If I am using TCE for cleaning today, and if I am having pulmonary problem for the employees of my company, I should know there is a significant difference between what is and what should be. That is the effect I get when I use TCE and the effect I get when I use a substitute for TCE. So your ability to find out a significant difference between what is and what should be, that is what I call the engineering mindset. The engineering mindset alone can differentiate and discriminate between what is possible, what is soluble, and what is insoluble as on today. That epistemological methodology is shown over the diagram here. That's a detailed version of that. Now I come to the GRI. This is what I call the engineers reporting tool, global reporting tool, which many people have taken their certificate. This has two components. Within the company, with your colleagues and with your management, all through your hierarchy, you can have an excellent equilibrium by internalizing the situation in the company. Now, you have immediate stakeholders just outside the compound. For example, if Asian Paints is having a paints factory and there is a school around there, and any solvent smell coming to that area will be automatically stopped by the company because it is part of its moral responsibility and social obligation. So there are two aspects of it. One, internal, which engineers alone can do it, and an external goodwill being, not only goodwill, social responsibility being enacted, that also engineers alone can do it. So that is why I was emphasizing on global reporting technique. Now I am coming to another aspect, which is called the technological maturity. Every engineer should be able to find out whether she or he is dealing with any mature technology or a mature technology or an overripe technology. Now, on looking at it and reading from textbooks, you will never know whether technology is mature or immature. Textbooks will give excellent, elegant examples of what it is. But beyond that, a technology cannot be practiced by reading the textbook. I can give you the recipe for making the softest idli, but when you make it, you undergo through the process, it will be like stones fit to be thrown at your dogs. The ability to create a texture and a softness, that is part of a process of engineering design and familiarity with the details. For example, if you look at any technical maturity list of desalination technology, they now technology, desalination technology is very ripe and is being employed for the last 40 years. Fine. It has been employed in a large scale. That is called the macro judgment on it. From the macro judgment, you have to come to the micro judgment, to the mini judgment, and then in your locality, you have to apply it to the nano judgment level. I want water from brackish water for 25 people in a village. I cannot apply Saudi Arabian technology of desalination for this. That is where technological maturity has to be recognized, evaluated, appreciated, and applied. Now, I have a set of, that's a topic by itself, I shall not go into the details, but the technology vision Kotkar has evaluated several technologies and it is now available to us in this form. For example, if you want to know what is the situation with respect to real-time dense spatial air quality monitoring, not readily available. All technologies have been classified into 4 classes. Readily available, available in the lab, third category, more applied and directed research has to be done, and fourth, at proof of concept or at a conceptual level. So at a gross level, the moment a technology is mentioned, an engineer should be able to jump to the conclusion that this is a ready technology, this is the technology in the laboratory, this is a technology which is to be developed with a little more directed research, and this is only a concept which is yet to be proof of concept to be developed. Like that, technologies are available for a huge number. I am not going into the details because each one will be a talk by itself. But remember, it is enough if you understand that technological maturity and technology management lectures will involve assessment of technologies and their status. When I have now given the general view of technologies, and can we have a break for 5 minutes now and reassemble?
Sure,
Is
sir. Sure, sir. Sure, sir.
Marin Joseph is there, Professor?
Yeah,
Can
yeah, sure, sir. Sure, sir. I'm there. I can hear you.
Thank you, thank you.
So, so we'll rejoin by
5 minutes. By
5 minutes. Okay, okay. Sure, sir. We'll
3
join.
to
Okay.
now, 3:09 we will start.
Yeah. Okay. Dear participants, we'll break for this break, and please rejoin by 3:09.
Sustainable mega, medium, mini, micro, nuclear power, desalination, electrothermal process, electrolytic, Indian study cases.
Okay, dear participants, please rejoin the session.
All of us are back.
Yes, sir, we are ready.
Right. So now I am to my second session, and here I will deal with sustainable projects, big and small. And the areas I would like to cover now as case studies will be nuclear power, desalination, electrothermal sustainable phosphorus, sustainable hydrogen, and an approach to the management of electronic waste. It all started long ago, 1954. Two figures which may not be in the memory, which I am sure is not in the memory of the current generation of engineers. Eisenhower, US President, and to his left is Lewis Strauss, Chairman of the US Atomic Energy Commission. They were having a very brief moment in which Lewis Strauss went on historic record that energy, electrical energy will be too cheap to meter. There will be no need for electrical kWh meters. Atomic energy will produce it in such large, abundant, infinite amount. There is no need for measurement. That was the promise which Levi Strauss gave to Dwight Eisenhower, United States. That is the beginning of a dream that later turned sour. That doesn't matter. But in that, there is a promise of an energy other than oil, other than fossil fuel. There we start. Now, following that, that was the era, the nuclear era. And the hero of India was Dr. Homi Jahangir Baba. Now, in order to initiate this country at the national level, at the policy level, and at the technical level, Dr. Baba had excellent relationship with the Prime Minister of the country, Jawaharlal Nehru. In fact, only two people have the guts to call Nehru Bhai, and Homi Baba used to call Jawaharlal Nehru Bhai. And he put up the Atomic Energy Commission proposal to him, and the files were signed, and the nuclear India was born. This entry of India into the nuclear club at a time when we were a very poor developing country is thanks to the far-sighted, forward-looking imagination of both Dr. Baba and Jawaharlal Nehru. Now, in the case of, to make a case for India, that India should become nuclear, that's a bit difficult. We have low quantity of uranium. We do not have adequate amount at all. Therefore, we thought we will have a three-stage program. The three-stage program consists of, we use pressurized heavy water reactors, and with the available uranium in the country, for 30 years. 30 years is sustainable in terms of that period. Then we thought if we put these uranium reactors, natural uranium, heavy water moderated reactors, we'll get plutonium as a breeder, and that will take us another 30 years. So 60 years out. Then we have probably that was the most promising part of it. In the black sands of Kerala, 55 kilometer, 5 kilometer wide on the Koilon belt up to Kanyakumari. We have 50,000 tons of monazite, which contains 50,000 tons of thorium in the monazite. This thorium, normally we divide nuclear fuel into two classes, fissile material and fertile material. Fissile materials like uranium-235 and 238 are directly fissionable. That is, you take a uranium atom, bombard it with a neutron, splits into barium and krypton, and use 2-3 neutrons. One of those neutrons coming from a uranium-235 fission goes into a uranium-238, becomes uranium-239, protacting into 239 by beta decay and becomes plutonium, again a fissile material. That is called breeding plutonium from uranium. Thereafter, when the plutonium reactors are in operation, we put thorium as a blanket into that reactor stage 2. Thorium atomic number is, mass number is 232. 232 plus 1, it becomes thorium 233. Then it becomes beta decay and produces uranium 233. So that is the nuclear chemistry and nuclear physics, which shows a promising future for this country. Now comes the great dream of Homi Bhabha died, the second chairman of the Atomic Energy Commission. Vikram Sarabhai came into power. And Vikram Sarabhai had got one of the most, I would say, the grandiose plans. Look, put uranium into the reactor, get rice, wheat, and for fertilizers, materials of human use would come. Input is uranium, output is food materials and drinking water. Drinking water, food, and materials for industry, they should come out. This was the grand old concept. And that concept, he gave it to a chemical engineer from Calicut, Dr. M.P.S. Ramani, with whom I worked on this project for about 5 to 10 years. And this is what we call the nuclear-powered agro-industrial complex, which we tried to develop in the Bhabha Atomic Research Center. The origin of this process is from the nuclear laboratories called ORNL, Oak Ridge National Laboratory. That is where the proof of concept was first minted. Now, they said that if you have a 2000 megawatt electrical reactor, we can have 4 million cubic meter of desalinated water, and we can have 300,000 acre of a food factory, and we can feed 6 million consumers. That was a compact diagram which Oak Ridge National Laboratory developed. Dr. Sarabhai asked Dr. Ramani to go to Oak Ridge, stay with them, understand the concepts, and find out all the hyperfine splittings of that, come back to India, and we formed a nuclear-powered agro-industrial complex study team, which operated on. Now, looking back, and if we retrofit that concept into SDGs, you will find that the agro-industrial complex is built for energy, food, and water. That is, those SDGs could have been amply met by the application of the Nuplex concept. Now, this is the equation I mentioned, the uranium 235 to 236. Now, over there you will find the Kudangulam reactor. Today, Kudangulam reactor is operating, and we have enormous amount of power coming from there. We have 22 nuclear reactors in this country producing about around 7,000 megawatt installed capacity. So that's what the nuclear India's profile looks like. Although we did not realize in physical terms in a nuclear power agro-industrial complex, the essential 4 elements of that has been met completely. Before that, I would like to, I have earlier stated, I have also argued, right now I will give you the substantial data with respect to the sustainability of nuclear power. Nuclear power as a symbol of sustainability. If you look at all the sources of power, right from gas to biomass to coal to geothermal, wind and solar, you will find the intensity of utilization of material, or what we call material intensivity of every energy source. If you find out and put it in terms of the amount of concrete required, the amount of metals required, and the amount of cement and glass required, you will find solar stands with high need for metals, and a large amount of hydro is totally based on concrete, whereas you come to nuclear, a pressurized heavy water reactor, it needs very little concrete and very little metals. So if you look at the material complexity, in fact, that is why I showed the periodic table in the first instance itself. You will find the material usage in the nuclear industry is very low. You can also find from this graph, from this picture, that the land use pattern for the nuclear is pretty low, absolutely low. In fact, it's the least consumption of land. We don't need a lot of land for running a nuclear reactors, whereas we need large quantity, large areas, both for wind, hydro, and biomass. And if you go to the carbon neutrality of nuclear power, which is the third valid point in terms of nuclear power sustainability, is that the grams of carbon dioxide per kilowatt hour, the highest, of course, everybody knows is from coal and petroleum, and the least comes from the wind. But next to penultimate left to the wind, there stands nuclear. So on the environmental impact side, there is a triple gain as far as nuclear power is concerned. Now, one thing which will be worrying most of you is that yes, nuclear power may be good or is good, but what will you do with the radioactive waste? I must tell you, I have been working as the engineer in charge of the radioactive waste management of the atomic energy establishment, and it's called a burial ground. So I was the chief of the burial ground for about 5 years, and I know what to do and what not to do. We have a very clear systematic method of disposing the radioactive material in the ground itself. If the radioactive material is very low, we have earth trenches. Now you may wonder, if you put it in earth trench, will it not escape? Yes, we have earth trenches which have been created with chemical barriers around. That is the geohydrology of the system, so that there is zero release of radioactive element from the earth trench to the geohydrology of the area. So engineered earth trenches of that type. Then we have a intermediate level. Intermediate level wastes are still kept for some time on the ground disposal facilities with appropriate concrete structures protecting, including top concrete, which can withstand the impact of airplane crashes. So we have engineered burial sites where all radioactive waste can be managed. We do not dilute and disperse to the environment. We concentrate and contain, and there is a chemical technology available that all the radioactive waste are concentrated and immobilized in borosilicate glass. And this borosilicate glass can be kept in abandoned mines like the Kolar gold fields. And you might still ask the hypothetical question. You might keep it deep in underground mine, 2 kilometers, 3 kilometers down, but will it not escape and come to the ground level further? No, there was a natural reactor which operated in natural conditions in South Africa called the Okla phenomenon, where without any human intervention, about a few million years ago, the reactor operated, and the fission products generated by that natural reactor Okla phenomenon is still remaining constant to that area itself. So confinement to an area in a geological formation has been well established. So I think the radioactive question has now been well settled, and the nuclear energy people need not worry about that. Now, water is extremely important as an SDG product, and that is why desalination by nuclear power is very important. Let us go to the Valayar area, the Coca-Cola factory, beverages corporation, Hindustan Beverage Corporation. To make one bottle of beverage, you need 3 bottles of water. That means 2 bottles will become wastewater and 1 bottle become potable beverage. This is the general ratio. Now, these plants, beverage plants, were operating with underground water, and underground water is a fixed quantity. So when water was taken from this, the farmers felt that they were not getting adequate water in their wells. So there is an agitation coming from for want of water. They also found out that there are certain materials which is called heavy metals, toxic metals like cadmium, lead, and mercury. From the operation from the plant, escaped into the farm fields. And this rice plant has got a remarkable capability of absorbing and translocating the contaminants from the water, and that concentrated in the rice, and we got toxic pollutants in the rice. This has been the problem. Therefore, people objected, the scientific community objected, popular science movements came up, water became an issue, water became an international issue, that industry should not play with the limited resources of groundwater, and the UN declaration, Plachimada Water Declaration came into being thanks to this effort of the Kerala IP. Now we come to the desalination technology. When in the original concept of Sarahai and Ramani, nuclear power will be available in large quantity, and that will be used for seawater desalination. All nuclear reactors, you understand, are placed very near seasides, because we can have the cooling water drawn from that, and it can be returned to that when the thermal gradient is less than 10 degrees Celsius. That is a basic principle of locating reactors near huge water bodies, either Rana Pratap Sagar or near the seashore like Alpakam or Kudangulam, like that. So therefore, access or proximity to water is well assured. So therefore, desalination technologies were developed as a result of the agro-industrial complex. The major technologies developed are, seawater contains 35,000 parts per million salts, and it has to be brought to 500 ppm for the WHO standards. That is the ratio. But aggressively pure, zero TDS water can be created by the methods shown over here. You can use multi-stage flash distillation, MSF, or you can use a multi-effect distillation, vapor compression. And more than that, what we have developed in great depth was the reverse osmosis membrane and electrodialysis. Those were the methods developed in this process. And let me go a little to the membrane technology, because that's a project which we did in India. Membranes can be, we have different types of membranes. We have the membranes with the large pores, which are used for microfiltration, slightly smaller pores for ultrafiltration, still smaller for nanofiltration, and ultimately the reverse osmosis, which will not allow even the coronavirus to get in. So that is the viral protection which we are able to provide for membrane technology. So we started, today we have several desalination plants in India, some of them are. The first plant which I had the privilege of operating was in Andhra Pradesh, in Gudur village. There we started, we had about 200 people working in a village, and the water over there is brackish, salty. That means it has about 5,000 to 6,000 parts per million of salts. So this is an original, it's about 15 years ago, and we didn't have the advanced polymembranes of the DuPont type. We had our own native papadum-like membrane, I call them. We take cellulose, treat it with acetic acid. We form 2.5, cellulose 2.5 membrane, and that membrane is cast like a papadum. And with polycarbonate plates, we keep it in between. We use a high pressure reflex pump, and with that, we produce drinking water. That is, input water will be 5,000 ppm, our output water will be say 200 ppm. So I went there along with my friends, three of us, went to Gudur, put up the plant, started getting the output. We gave to the villagers. They were very happy. It went for about 10 days. The plant worked well. It was well accepted. The reception given to us, and we were treated like heroes, because they could see the difference between brackish water and sweet water. The salty water and sweet water gave them difference. Then suddenly one day we came to know from our informers that the water which we are producing by reverse osmosis is being given to the buffaloes, and people have stopped drinking that. That was a real cultural shock for us. Then we inquired and we found out, when we are operating a reverse osmosis plant, the input water has to be acidified. The pH should be 6.5 or 6, so that the membrane does not foul or get damaged. For this purpose, we add a little acid. So a little acid is added to the input water, process water, then it goes, and then our membranes have a longer life. This is what we do, and this is a well-established practice. But we bought, when the acid we took was over, we bought it from a local battery manufacturer, and he sent a message, these scientists are taking acid from me, they're adding it to process water, and beware, this is a process for sterilization of the people in the village. So our program was labeled as a family planning program of the government, that this water is being acidified so that people are made sterile. And they started disusing this. This is one problem we had when we implemented a technology, an appropriate technology in the village. We did the same thing in another village in Gujarat called Maliga village. There also we had the similar problem, because bad news travels faster than the velocity of light. That is the reason why Everybody thought, and that was an aggressive campaign, sociological campaign was going on for containing the population explosion. So every technology was suspect, and our technology was also suspect. If you want to do optimization of a desalination process, we have the methodology now available, and you can find out this. If you whether use a multi-stage or a single-stage membrane process, you have to do an economic analysis, and the environmental analysis is the reject water. The permeate comes out, which is fit for consumption, and the retentate has to be disposed of because it has a higher concentration of salts. What do we do with that? That has been the nagging and perplexing problem in this technology as yet. And the solution lies in recovering marine chemicals from that particularly. Of course, we can take sodium chloride first, calcium sulfate, we'll remove that. Now, when you have several technologies available on the same technology umbrella, let us say desalination technology, then the sustainability rankings of desalination technology of each subset is different. Here is an advanced technology called a TOPSIS technique for order performance of similarity to an ideal solution. This is applied, and we find that the low temperature multi-effect distillation is the most acceptable from the sustainability point of view, with a ranking close to 0.7. Below comes the multi-stage flash distillation, which is 0.56, and the vapor compression distillation is only 0.53, and reverse osmosis, which is being widely used in Saudi Arabia and in large number of countries. The sustainability of that technology, that subset of desalination technology, is only 0.41. Now the question comes, when you have low temperature MED at 0.7 and when you have RO at 0.4, what will you choose? Why will you choose? That is where the Reisendacre of methodological ranking is to be done, which has now become a refined art among desalination technology. So I give you a brief introduction, and today desalination technology is well developed, and we have got what is known as a point of use desalination filter. In Mumbai, the water quality supplied is less than 500 ppm, and we use reverse technology, reverse osmosis plants, small plants, domestic plants, to fit to the household supply. This is absolutely unnecessary, because 500 ppm, you do not use RO technology for this. And all that you need is not an RO membrane, you need only a micro filter is more than enough for removing. And that is why there is a misunderstanding of this technology. But technology is well developed in this country, and we can do it, and we have been doing that. Now I want to explain to the second concept, which is called sustainable phosphorus, which Sarabhai and Ramani were doing. In this country, we need phosphatic fertilizers. And phosphatic fertilizer, the NPK, the P stands for phosphorus. Phosphorus is made into a fertilizer in the form of ammonium phosphate. And we bring rock phosphate from abroad. Jordan and Morocco are the two places from where we import our rock phosphates. We also import sulfuric acid, either directly as sulfuric acid or as sulfur, and then convert it to sulfuric acid. So we have two raw materials with a long logistic chain coming from Morocco and Saudi Arabia. These are the places where phosphorus and sulfur are coming. Then we do the chemical processing over here. This is called the unsustainable wet process of phosphorus. Now, to displace this and to substitute a sustainable process of production of phosphorus, Sarabhai and Ramani had a concept, and we operated this plant we have a plant working for the last 5 years. The technology is well proven. What we do is, the Indian rock phosphate is notoriously poor in grade. Not only notoriously poor in grade, but also has incompatible elements in the mineral. For example, we have rock phosphate in Rajasthan, Udaipur and Jodhpur. The Udaipur rock phosphate and the Jodhpur rock phosphate contains silica, and the amount of phosphate PO4 in the mineral is very low. So we have a poor grade silica contaminated rock phosphate. Now the agro-industrial complex project, sustainable project, which we were discussing and which is implemented, was the phosphorus was brought in, and we used an electrothermal phosphorus. In an electrothermal phosphorus, coal and silica are added, and when the rock phosphate is heated in that, phosphorus comes out as a vapor, P4, 4 atoms of phosphorus in one molecule, phosphorus comes out, and you get a slag of calcium silicate which is separated out. We are not getting phosphoric acid directly, but elemental phosphorus can be prepared in a sustainable way using low-grade phosphate available indigenously without bringing from Morocco, without bringing the high grade from Morocco and the sulfur from elsewhere. So the local utilization of this low-grade rock phosphate will produce us elemental phosphorus. Once you get elemental phosphorus, a steam reformation by adding sulfuric by H2O process will yield phosphoric acid. So this rooted phosphoric acid through elemental phosphorus with steam distillation is well established, and we have been running this pilot plant 1 ton a day for nearly 3 years, and the technology has been transferred to other ones. So that is a chemical engineering process. This is a phosphorus plant we have operated. It's running. Now we have the hydrogen economy. So what Sarabhai said was we should have a hydrogen economy. We have seawater desalination, we have phosphatic fertilizers, and we have ammonium fertilizers, because energy need not be transmitted, distribution of electricity can be reduced, and we can have energy intensive industries built around the nuclear reactor. That's the whole concept of a complex. So there we thought, since desalinated water is already produced, we shall split the water and produce hydrogen and use that hydrogen as a fuel, a liquid fuel for transportation. So we ran Willis Jeep with the hydrogen propagated in this way and showed and the proof of concept was well proven. Later, having shown that elemental hydrogen has problems of transportation and hazard, we were looking at the fuel cell concept that was also developed as part of this program. So my submission now is this: if you have a small project on, which most of us would be able to do at the engineering college level, a sustainability project design with a solar small RO plant. We are not going to use electricity, but at a with a solar energy and a very small plant. What are the 92 checklists which we should do before we design this project? I leave this exercise to you in detail. Now I will come to the concluding session of my project, which is called the e-waste project. Now the e-waste project, I don't have to tell the electronics engineers the waste which we produce. Every gadget which we use today is an e-waste tomorrow. And not only that, you will find the Apple design concept now. The earphones they build is built for 2 years. You cannot open it, you cannot repair it, you cannot touch it anyway. After 2 years, it comes to its cycle. So therefore, e-waste management and its engagement or couplings with the SDGs are shown over here. Now, if you look at the waste arisings from 2014 onwards, we have reached extremely high levels, and these levels are going to be still higher. And most of this e-waste in India is managed by an informal sector. An informal sector which involves kachrawalas, binawalas, piyawalas, small kabaris, big kabaris, dismantlers, and middlemen. This is how the recycling industry starts. So here you have got a set of PCBs assembled, and the details of e-waste coming from different parts of your computers and cell phones are given over here. And this is the hazard list that is done. In the batteries, you have got cadmium, lead, and mercury. Of course, we have got the lithium now. Lithium should be seen from the sustainability angle. Goldman and Sachs now believe that the expected life expectancy of lithium for lithium-ion batteries is 50 years. After 50 years, unless all the lithium that has gone into the batteries are recycled back, there will be no fresh lithium available for mining. So that every element will have this. Now I am referring to the compact fluorescent tube production in India. This is a pretty large number. And CFL is extremely important for us because according to the Ministry of Environment and Forest, this is not only an electronic waste, it's called an hazardous electronic waste. The tube light as well as the CFL carry a phosphor inside that. It also carries mercury about 4 milligram to 8 milligram, depending upon the level that is going into a particular company's makeup. So mercury is being distributed through this. The moment you take a CFL and shatter it to smithereens, automatically mercury gets dispersed and you can get contaminated mercury into otherwise uncontaminated electronic waste by non-segregation at the source. These are the 40 elements of your periodic table. All these 40 elements are used there. For example, your touch screen. Look at indium oxide. Indium oxide is the oxide which is responsible for conducting, for giving you conductivity phenomena on the screen. So you will find extremely difficult metals which are on the decline being used, and therefore recovery is a must. This is the classical circular economy where reduce, repair, rental, remanufacture, recycle. Repair and recycle is the ultimate solution for this. And recycling is a big industry. Smartphones, these are the figures we have about, in use now, about 7.5 billion smartphones. And these are the metals which we can recover. But when you are recovering, you must be very careful. For example, iron, iron you can leave it like that. Gold and silver have to be recovered. Now, if gold and silver have to be recovered, the process of recovery is through cyanide. When potassium cyanide is used to complex gold and silver on recovery, then the chemical leasing principle which Martin Polyakov mentioned has to be followed. That is why that periodic table of 90 elements comes in every time. You want to recover copper, see the 92 guidelines of design. If you want to recover copper, find out the reasons for that. That's how it runs. So this is the team which did the electronic waste project. These are 3 engineers, myself a nuclear engineer. To my right is my daughter, an electrical engineer from VJTI. To my left, my grandson, an electrical and electronic engineer from Imperial College London. 3 of us decided that we should do an electronic waste management program in Mumbai at a small scale as a family affair. So we did this. This is a small engineering family. We started that. And this is the status of electronic waste in Mumbai. This is from Dharavi, where you will find women and children and transgenders all working in this area. And we allowed them, we went to one group of flats, 500 flats were there in a nearby complex, and we told them we will give them, Philips helped us. Philips fluorescent lamp gave us containers. We asked them to be segregate, and you will find CFL. CFL is the villain in the program because of the mercury. Tube lights also contain mercury, and we segregated. Then we send it to transportation is arranged, and you will find a box here, X-Power box. This box was distributed to 50 schools and colleges across Bombay, and all the electronic waste were collected. Then we have a mechanism with the Lions Club to bring it together. So a logistic mechanism, not a very great work, but a logistic chain was provided because we know the waste arisings and the replenishment time calculated. And all that we could do at this point was to deliver to a governmental agency approved to process electronic waste in, that's about 20 kilometers from the city of Mumbai, handed it over to them. They will do the technical part of it. Now, that is one aspect. Along with that, we thought, what can we do? And we started a small-scale research in chemical engineering. My colleague at a university in Chennai doing that. We are scraping the tube light and taking out the phosphor out of that. The phosphor consists of rare earth oxides. And rare earth oxides at the moment, although we have a large number of rare earth minerals in the country. Most throughout the world, the single source of supply chain for rare earth phosphorus is China. And the moment that supply chain is cut off, tube lights will not burn anywhere else. Therefore, we are thinking at a research level, we have scraped the inside and taken the phosphorus out of it. We have dissolved it in a solvent, and we have complexed it with a complexing agent for those lanthanides. And we are using a membrane to permeate and the retentate differentiation. And a concentrated solution of rare earth phosphates is being obtained at a laboratory, not even at the lab scale, the gram level. So that work has been initiated by a group of my colleagues in the chemical engineering department in a Chennai University as part of this electronic development program. So in all I wanted to say was this. It is possible to have a small scale program. We can scale it up. And since the Ministry of Environment and Forest has a mechanism and a few places which are designated repositories where the capacity for incineration, segregation, and retrieval of material exists, delivering to that, and also concurrently produce a technology, a chemical technology, which can extract the strategic critical materials from electronic waste, including metal recovery by reverse osmosis, because that's where the technology exists for us. That is what we can do that. And this is the detailed program for rare earth elements extraction. Either you can use it and send it, or you can close the loop, how to create a circular economy for the phosphorus of the country. That's what I've done. And this is my concluding slide. And I stopped with a quotation from Albert Einstein. He said that concern for man and his fate must be the chief endeavor of all scientific activity. Never forget this in the midst of your equations and graph. Albert Einstein is a physicist. Albert Einstein wanted to become an engineer. And if he had become an engineer, he would have slightly rewritten this text and would have written, concern for man and his fate must be the chief endeavor of all engineering activity. Never forget this in the midst of your equations and graphs. Thank you.
Thank you, sir. Shall we move on to the question answer session?
Yes.
Okay, so first question.
Yeah.
Sir, were you able to continue the desalination procedure by convincing the people?
Yes, very interesting question. Yes. First of all, we drank the water.
Okay.
That is only because this drinking the water. But then they said these are some senior people coming and making a show of that. See, making the people believe. For example, in Singapore, grey water is converted into fresh water by a great desalination plant. After getting the desalinated water, what they do in Singapore is they put it to a normal reservoir, dilute it with natural water, and they give it for human consumption. But the Prime Minister of Singapore every morning takes the directly desalted water and drinks to show to the people, I am drinking desalted water without the dilution through the pot. So after a while, we brought more people, including some of our colleagues, to the plant because press people came and all of them drank, and we had to make more a PR show of the water. And ultimately it was accepted, and there was no problem. But it took quite an amount of time because they have touched a sensitive chord in human culture, and it is very difficult to erase impressions created by negative reporting. So we did that, and finally the plants worked, and they asked for a large scale up. And under the Rajiv Gandhi Technology Mission, more such brackish water conversion plants were created. There was no problem.
Okay, sir. That is a good leadership quality that we should imbibe from you. Thank you, sir. And the question about e-waste problem, how dangerous is it? Is it manageable?
It is truly manageable. At the policy level, Government of India will be having the extended producer's responsibility, EPR, into action. That is the producer, whichever is the company which is producing, they must have a buyback program. If I buy a CFL from a retailer, I should be able to send it back to him and get a discount for that. So this mechanism of policy of collecting and gathering it back to the source is one aspect. Two, There are fake manufacturers, substandard producers. For every article in the market, you will also find a fake product. Those things will get into the gray market. Therefore, all that you can do is have NGOs, non-governmental organizations, to enter the field and see that the rag pickers do not deal with that. There should be education by the social groups to the rag pickers that this contains mercury. There was a disease called Minamata disease. People in Japan have suffered. So let us not do this. You don't take this type of waste. Then you will find in Mumbai, when a copper wire is there, they burn the copper wire to take the copper out. This is the plastic polyvinyl chloride outside burns. When polyvinyl chloride is burnt in an open flame, what you get is dioxin and a number of other toxic chemicals. All of them are being inhaled by children. So there is a strong need for stopping child labor in the electronic waste. With the enforcement of a strong Child Labor Act in this, plus an extended producer responsibility, will solve it at two levels. Technologically, there is no problem. E-waste technology is available. And not only that, e-waste technology gathering should go in greater speed, and we should be able to use the waste collected as urban mining. Presently, for mining these minerals, we go to places which are rich sources of these raw materials. Now, if you look at the thermodynamics of it, entropy is increasing. You are taking a small amount of rich ore from some area, purifying it, then distributed in some 1 million mobile phones. So 1 gram which was lying over there is now in the form of 10,000 products in 10,000 hands. What happens is a disorder function. Entropy is defined as a measure of a disorder of a system. We are creating this entropy by all our processes. But if you can intervene and collect them together and then engineeringly recover it, recovery is the only solution for this. Technology exists, appropriate policy awareness is there. If NGOs start operating at the level of child labor, we should be able to do that. So there is a good bit, and many chemical engineers will be able to retrieve small plants, viable plants, which will recover precious metals from electronic materials. And in fact, DuPont has a wonderful way of taking. See, DuPont is the leader in plastics. Every polymer they make, they have a protected property, and IPR has been protected. This polymer can be converted into a virgin polymer, and they can reconstitute the polymer. Sun Microsystem has got a system of buyback their materials. So automobile industry is also now going into that. So industrial cycle in Industrial Revolution 3 will be seeing a different phase of distribution and collection.
Thank you, sir. The last question.
Yeah.
What will be the condition of our planet in 2050? Will it be a better place to live in?
It is entirely for you engineers to decide what you want. Design is destiny. Destiny is in your hands. You have the technology, you have all the engineering technology, you have all the SDGs in your hand, and if you just apply them, this will be paradise on earth.
Okay, sir. Thank you. That was the end of the question and answer session. Thank you, sir, for your enlightening talk. You have unveiled the histories to the young engineers. Your narration of BABA's sustainable nuclear program was really spectacular and indeed motivates us to gain more knowledge. You have given us a brief description about India's growth as a nuclear power. The case studies discussed were really informative and depicts your contribution as a nuclear engineer. Sir has also thrown light on e-waste generation and management. Thank you, sir, for this effective knowledge sharing session. Thank you once again. Jayaraman sir, we'll be very happy if you would join the valedictory session also, which will begin soon.
Oh, okay, I am here, yes.
Okay, sir, thank you.
I'll let him go.
Dear participants, meanwhile, you can fill out your attendance and feedback in the following link that is given in the chat box. Okay. Dear participants, meanwhile, you can fill the attendance and feedback in the link given in the chat box. We'll begin our valedictory session soon. Okay, now, dear all, let us all move on to the closing ceremony of our STTP. Acknowledging the good that you already have in your life is the foundation for all abundance. Let us use these moments to express our gratitude to all who made this STTP a grand success. We are really grateful to Professor KG Sadish Kumar, the head, Department of ECE, Amarjyoti College of Engineering, for his support in the successful conduction of the STTP. I earnestly request Sadish sir to address the gathering.
Good afternoon to one and all who listened to me in this fine evening. We are almost coming to the end of the 6 days AICTE sponsored STTP on paradigm shift in assessment and evaluation practices for engineering graduates. We started our training program with the inaugural function, followed by first session on creating awareness of outcome-based education and outcome-based assessment by Dr. Preeti Bajaj, Vice Chancellor, Galgothias University. And now we are ending the session, this 12th section by Dr. A.P. Jayaraman sir, retired scientist and former head of media relations BAC, with the wonderful discussions and talk on the need for sustainability in project designs by his own practice, what he does in Bombay regarding the e-waste management. These 12 luminaries took us to the ocean of the topic paradigm shift in assessment and evaluation practices for engineering graduates. They have created a spark in us to make a shift. I would like to add on this, shift should start from us. We the faculties, we are the formaters of the engineering graduates. These young guys around the age of 18 coming with lot of enthusiasm, expectations and dream. Nurturing their dreams and making them as a sellable product with high demand in the employment market lies in our shoulder. So we should have self-assessment and self-evaluation how much we are conversant with the OBE and OBA. For that, we have a self-evaluation on us, how much knowledgeable we are, what we are teaching, why we are teaching that particular course, and how much it is related with the current scenario, and how it will be useful for their future endeavors. If we can answer to these questions in a convincing manner, sure, students will like the topic and they will learn themselves. During these sessions, some of the participant question as told, this OBE and OBA is only for documentation. We do some tabulations, finding out the attainment and showing to the NBA, National Accreditation Agency. But dear participants, dear my colleagues, this depends upon our shoulder, whether it is a tabulation or whether it is a practically we does it. If we can plan meticulously, starting from our course objective, course outcome, course delivery method, evaluation method, attainment calculation, and finding the gap between the set target and achieved target, sure, and if we can, bridge the gap by complementing with additional training, maybe on theoretical, hands-on, or industrial tie-up or internship, then our conventional concept of engineering education will change and can make our student a sellable product. For that, we should set the target with a thorough deep knowledge of the topic and how much we expect from the students and how can we make them to attain that value by proper directions, guidance and motivation. If the directions and motivations are in proper direction, sure, the existing situations will shift in a good way. For an example, if you see today, we have more than hundreds of participants attending this STTP from different parts of the country. from our own workplaces without much affecting the routine life. This was only possible due to this online mode. Earlier, when the AICTE sanctioned some funded project or the funded training program, the amount spent for the travel, for the food, and many angle, if you see, it's much higher than the amount of information what we share. Now, almost same amount of information we could share with minimum wastage of money, wastage of time. Even in the sustainable way, if we speak, we are saving, we can make the zero carbon conditions, all this, because we are not traveling for this training program. Suppose we are going to attend the same program in Delhi, we have to travel throughout the from Kerala to Trivandrum, Kerala to Delhi by air or train or whichever the mode, or wastage can be avoided by such this. And this training program made more effective than what we were following earlier with the conventional method. So nowadays, we are using almost all the different learning management system like Moodle or Zoom or Microsoft Team, Google Meet, or many more tools for delivering our class nowadays. And these all were existing before this COVID pandemic situation, but rarely people use this. So situation demanded us to change from our conventional method to the new online mode. So this paradigm shift in our delivery method with almost the same effect with minimum wastage of time and money. At the same time, more effective learning is provided if provided the learners or the trainees are 100% sincere. That should come from the individual. We should train our youngsters, young students to be a sincere. We cannot make them to be sincere by just delivering lectures, only by demonstrating through our actions. We the faculty, we the formators we should keep practicing all this sincere activity through our activities. Surely we will succeed. My best wishes and prayers for all participants to succeed in your goal to make your students a high demand sellable product in the market. Then situation will change. Employment is not the problem, employability is the problem. So we should make our youngsters employable. Surely they can contribute for the sustainable development of our nation. I take this opportunity to thank our beloved dear colleague and the coordinator of the program, Dr. Teresa Emina Mahesh, for selecting the topic, arranging the resource persons with meticulous planning, scheduling, and implementing with utmost care and 100% commitment. I could not find any shortcomings, and even the participant, through their feedback, always giving about the session an excellent comment about the program, time management, question answering, all this. All this was possible due to her meticulous planning, and with the team spirit of ECE, the entire team, entire department team under the leadership of her made this program a grand success. My congrats and thanks to all my dear colleagues. You made this program a grand success. You made the glory to the department, in turn to the college, and to the AICTE as a whole for organizing this program. Dear participants, hoping to meet you for the forthcoming sections. We have 2 more phases of the same area, and starting on 16th November and 7th December, and also department is organizing another adult FTP on IoT in the first week of January. Hoping to meet you all. I once again thank all the luminaries who delivered the talks starting from first day till ending with the Jayaraman sir. Once again, I thank you. Thank you. I remain. Wish you all the best.
Thank you, sir, for your warm words. American business magnate, software developer, and philanthropist, Mr. Bill Gates said, "We all need people who give us feedback. That is how we improve." I use this opportunity to request our participants to share your feedback and suggestions so that we can improve our upcoming phases of STTP. Participants who are willing to give feedback, please unmute your audio, connect to your video if possible, introduce yourself and share your feedback.
Good evening, madam. Hello. Good evening,
Good evening,
madam.
sir. Good evening, sir.
Yeah, good evening. This is Dr. Jnaneshwar. Shall I go ahead, ma'am?
Sure,
With
sir.
your
Sure, sir.
permission?
Sure, sir.
Yeah,
Thank you.
good.
Thank you.
Yeah, good evening, madam. Good evening, everybody. My name is Dr. Jnaneshwar Paimarur. I'm working as assistant professor and PGP coordinator, postgraduate program coordinator in Department of Business Administration in NMM Institute of Technology. We are autonomous institution in Nitte in rural part of Karnataka. This is in fact my second AICTE sponsored STTP. I have considered COVID-19 not as a pandemic, but and as an opportunity to upgrade my knowledge. So I was very clear that I have to attend and gain knowledge from STTPs this time. So I would like to thank the organizing team for meticulously chalking out the entire program. I think the team has left no stone unturned with regard to the topic coverage on assessment and evaluation practices. Our department here had applied for NBA accreditation, but due to pandemic early this year, the peer team could not visit us on time. So although we applied for NBA because management didn't have outcome based in our previous cycle, most of us were not much oriented with regard to the nitty-gritties of outcome-based education, right from setting up the PO, CO, PO, mapping, stakeholders, and so on. Now I've come to know the NBA accreditation is not just a number game, not just getting a grade, but I've learned about how value addition this would mean to me and my institute, my students, and various stakeholders would gain in the entire process. I'm very fortunate that I made a very wise decision of attending this online STTP organized by Amal Jati Engineering College, and I'm very confident that I can now stand on my own feet and orient my fellow colleagues on outcome-based management education. These speakers were really excellent and simply best of the best. So giving the session and speaker details in the brochure itself, the organizing team has shown how well organized they are. Also, without fail, I used to get email reminders every day with regard to the next day's schedule as well. So there was no chaos, no confusion at all. So STTP team has really done a very good job, and they really need a great round of applause. Let me clap from my end here. So I once again thank Kamal Jyoti management, STTP team, Terezi madam. I was in touch with Marin Joseph madam, and I look forward for attending more STTPs on other areas being organized by Amal Jyoti in future. Thank you so much for the opportunity. Thank you one and all.
Thank you, Dr. Jnaneshwar. Thank you for motivating us. Thank you. Thanks a lot.
No problem. Thank you, madam.
Over to other participants.
Hello, good evening, everyone. Am I audible?
Yes, yeah, ma'am, you are audible.
Hello, I am Kanaka Sevia. I'm Associate Professor from Department of Electrical and Electronics Engineering from Albertian Institute of Science and Technology, Kalamassery. I would also like to add that these 6 days of STTP on paradigm shift in assessment and evaluation practices for engineering graduates, it has been a wonderful experience for me, and I believe for all the participants too. Right from the first session on creating awareness on outcome-based education, Dr. Preeti ma'am, she has given a kickstart to the program, and which was carried forward with the same pace by all other resource persons also. Each and every session, it was highly informative and helpful. And I have seen that there were sessions which has thrown light on how to cover the program outcomes 6 to 12 also, which we usually not see in other training programs. And also we got a golden chance to listen and interact with eminent resource persons of various fields, their new ideas, technologies and all. And on personal lot, the day 3 session 1, it was really helpful for me as I have been working on the criteria 3 program outcomes and course outcomes in my college for accreditation works. I would also like to add on that all the arrangements, it was perfect, even in online mode. All the sessions, it started on right time. We were given all the schedules. As a whole, the program, it has succeeded to bring an insight in OB and its assessments. So I wholeheartedly appreciate and thank all the resource persons, management of Amal Jyoti Engineering College, the Department of EC, and the entire coordinating team headed by Dr. Yamuna ma'am, Marin ma'am, and everyone for conducting such a good program. Thank you.
Thank you, ma'am. Expecting your participation in the upcoming STTPs also. Thank you, ma'am.
Definitely. Thank you.
Okay, thank you, ma'am. Okay, over to other participants. If you have any feedbacks, if you have any suggestions, we are very happy to hear from you so that we can improve in our next STTPs. Uma Uday Chandran, she has raised.
No. I'm sorry.
Oh,
Actually,
sorry.
it's Justin. It's my mother's phone.
Oh, it's okay. It's okay.
Yeah, I'm an assistant professor in biomedical engineering from TKM Institute of Technology, Kollam.
Okay, sir.
And actually, I have attended a very few FDPs. I think I'm a bit lazy in that things and so. But it's my first experience with Amal Jyoti's STTP in paradigm shift of assessment and evaluation, and it's very nice. And I have some doubts about my own profession and my assessments, which I have been doing to my students. So it has been sorted out, and I'm very happy to be a part of an FDP where we are getting every nuke and caller clear about what we can say. Everything is clear and noticed, and we have the queries raised and it is answered very perfectly, and we are very happy to have an FDP like. I'm very happy to have an FDP like this, and I'm thanking you everyone who is conducting this FDPs very perfectly, and you have shown a light on us to how to conduct an FDP, how this in a proper manner and proper timing, and so punctual and so helpful throughout the session. And thank you very much for your concerns.
Thank you, sir, for those nice words. Over to other participants.
Hello.
Yeah, yeah.
Hello.
Hello, Shivadanu, sir. You are
I am
audible, sir.
Shivadanu. Okay, I am Shivadanu from College of Engineering, Muttathara. But your course is sorted from Dr. Preeti madam and Jacob Phillips sir, also very useful for our accreditation and other purposes. Another thing I learned from your FDP. Normally in FDP online mode, few of them will be attended, but in your programs, more than 100 people always available in that full time of the programs. And another thing is excellent time management, and not only any point of view, every point of view, because you always you proved that you are the quality of providing the quality of education in Kerala. That is one thing, best of the best programs in I attended in so many AICTE programs I attended, but this one is the best thing. I never forget this type of programs. I am also eager to attend such type of program organized by your college. That is best. I thank to organizers and everybody's in the EC department and whole management. I thank to everybody's. Thank you.
Thank you, sir. And your queries actually energized the sessions also. Thank you, sir. Thank you. Over to other participants.
Madam, good afternoon, madam. This is Dr. K. Mani from Panimal Engineering College, Chennai.
Good afternoon, sir.
Yeah, good afternoon, madam. So all resourceful persons are delivered very nicely. And in fact, they are all expert in their field. And also, they all answered very nicely to all the questions which I have raised. So I am really happy, madam, and I am also willing in future if you organize such type of programs, so kindly intimate us, madam. Thank you so much, madam.
Thank you, sir. Sure, sir. We'll intimate you, and we hope to see you in the next STTPs also. Thank you, sir.
Thank you, madam. Thank you.
Okay. Over to other participants. Okay. Okay, thank you all. Thank you for your very constructive suggestions, feedback. This was a memorable day for all of us from the Department of EC, Amal Jyothi College of Engineering. Wholeheartedly thank all the participants for your participation, feedback, and your constructive suggestions. Thank you. Now I kindly request course coordinator Dr. Therese Yamuna Mahesh to deliver a vote of thanks.
Good evening to one and all gathered here, esteemed dignitaries, my team, and guest attendees. We take great pleasure to thank God Almighty for the successful completion of the phase 1 of the STTP on paradigm shift in assessment and evaluation practices for engineering graduates. Let me thank AICTE for sanctioning us this STTP in the most appropriate time when a change in education is foreseen by NEP. Our heartfelt gratitude to our guest today, Dr. A.P. Jayaraman sir, the person behind explanation of nuclear masala dosa and founder of STEAM, that is Science, Technology, Engineering, Arts and Max Academy. Thank you, sir, for your wonderful explanation on sustainability. We also thank all the resource persons, starting from Dr. Preeti Bajaj, Dr. Thomas Abraham, Sri Abraham Kurian IPS, Sri Amitabh Saxena, Sri Joe S. Karia, Sri A.G. Harindralal, Dr. Matthew P.A., Professor V.K. Damodaran, and Dr. Biju K. for being part of our STTP by sharing your expertise and valuable thoughts. I also thank our internal resource persons, Dr. Soni C. George and Dr. Jacob Philip. Our sincere thanks to our management, Principal Dr. S.V. Lakaparambal, Deans, Professor K.G. Sadish Kumar, HOD of ECE, Father Ruben Thotupuram, HOD of MCA, Dr. Jubi, Associate Professor MCA, for the wholehearted support and encouragement rendered to us. I have tons of gratitude to the hand-picked program coordinators of this STTP, Mr. Midun Joy, Ms. Mirin Joseph, and Ms. Deepa Joseph, for the excellent coordination in all activities. The three of them are the youngest in the department. It was their effort and enthusiasm that moved the program each day. It gives me extreme happiness to thank Mr. Anu Abraham Matthew, Mr. Matthew George, Mr. Ajay Matthew, Jason C.S., Karina T., Ms. Hindu Reena Varghese, Ms. Tessie Annie for the untiring work to execute this program. My thanks and gratitude to all other faculty from the department, especially Ms. Rosama Sebastian, Ms. Ria Maria, Ms. Presida, Ms. Darshana P., Ms. Ranjita Rajan, Mr. Aji Joseph, Mr. Jose, Mr. Shinto Sebastian, Ms. Divya Aras for their hard work for the success of the program. The contribution of our supporting staff, Mr. Radhakrishnan, Mr. Srijit, Ms. Jilimol, Ms. Manoj, deserve special mention. Our sincere gratitude to Father Jins Akaraparambal of our department for acting as a loving mentor throughout the program. Above all, I thank all the participants for making this STTP a reality. We know participants are the heart and soul of the STTP. Thank you very much. Also, the phase 2 of our STTP will be on NBA and NAC accreditation. This will be conducted from 16th to 21st of November. In phase 1, we were successful in delivering the concept. Next phase will be implementation with focus on NBA and NAC accreditations. So I request all the participants to attend phase 2 without fail, and I request you to bring in your friends too. Again, it gives me happiness and pleasure for your wonderful cooperation in making this STTP a success. Thank you all once again.
Thank you, Yamina Miss, for your words of gratitude. Dear participants, thank you once again for being the vital part of this STTP. We wish to see you in the coming phases of the STTP too. The link for attending the STTP assessment test we shared in the chat box as well as mail to you. I request dear participants to open your video so that we can go for a photography session. Dear participants, I request all the participants to turn on your camera so that we can go for a photography session.
Madam, you have not received an email. This is Dr. Nyaneshwar. I'm just checking, I'm just checking my inbox. I've not received an
Lavanya asked Vaishni to join.
Okay, thank you all. Thank you, dear participants, for all your support. The link for attending the STTP assessment test is shared in the chat box, and it will be mailed to you as well. It will be active for a duration of 1 hour. Thank you all. Thank you once again.